Chapter 6, Lesson 6, Scale Drawings and Models. So a scale drawing or a model is just something that's used to represent an object that's too big or too small to be drawn or built to actual size. And we have to remember that all measurements are proportional. So the lengths are proportional, the widths are proportional, the heights are proportional, the any circumference is proportional. Everything has the same proportion to one another in a scale drawing or model. Now the scale of that drawing or model is defined as the ratio, so it's two different measurements of a given length on the drawing or model to the corresponding length on the actual object. So if you notice, the first measurement that we're always given in the scale is the length on the drawing or model. The second measurement that we're given is the corresponding length of the actual object. So sometimes the first number is bigger, sometimes the first number is smaller. And it's usually written with the first measurement of 1. So it will say like 1 inch equals whatever, or 1 centimeter equals whatever, or 1 foot equals whatever, is usually how our scales are written. So for example, if we're asked to find the scale, we're always going to do it with the first unit of 1, or the first measure of 1. So find the scale on a model of a dragonfly. If the wing length is 4 centimeters on the model, the insect's actual wing length is 6 centimeters. And so if you remember, it said that our scale is always going to be the model over the actual. That's how our scale will always be. So we're going to say, okay, on the model, the wing is 4 centimeters, but it's actually 6 centimeters. And we want our scale to tell us that 1 centimeter on the drawing is how many centimeters on the actual object. And to solve this, we're going to solve our proportion. So 4 times x is 4x, 1 times 6 is 6. Those cross products are equal. Divide both sides by 4, and x is 1.5 or 1.5. So our scale is 1 centimeter equals 1.5 centimeters. And we don't need to put any other labels beyond that, because in a scale, we always know that this first one is for the model, and this one is for the actual. So we don't need to write that. This is just what we need to write, but we know that. Okay, so this tells us the blueprint of a skateboard ramp shows that its length is 11.4 inches. If the scale is 1 inch equals 6 feet, what is the actual length of the skateboard ramp? And so we're going to start by saying, okay, so the scale says that 1 inch is the same as 6 feet, but we want to know how many feet is our skateboard ramp if on our model or on the blueprint it's 11.4 inches. So we're going to say x equals, and we just do 11.4 times 6, and we get 68.4 feet. And that tells us that the length of the actual skateboard ramp is going to be 68.4 feet. Okay? So Lila is painting a mural on a wall at the community center that measures 18 feet long and 12 feet tall. The scale for her drawing is 1/4 inch equals 3 feet. How long and wide should her scale drawing be? And so we're going to say, okay, so my scale is 1/4 inch is the same as 3 feet. And we want to know, let's first do how long it's going to be. So I don't know how long her blueprint is, but I know that it's 18 feet. So now I'm going to cross multiply, and I'm going to get 4.5 equals 3x, divide by 3. And I know that her scale drawing should be 1.5 inches, and that 18 feet went with long, so it needs to be 1.5 inches long. And then I'm going to do the same thing. I'm going to say 1/4 inch is the same as 3 feet on the scale. And so I want to know if her mural is going to be 12 feet tall, how many inches. And so I say, okay, x times 3, 3x. 1/4 times 12, that's just divided by 4 is 3. Divide by 3, and x equals 1. And it should be 1 inch tall. So she's going to have just a little tiny blueprint on her for her scale drawing. All right, there's one thing that I forgot to include in your notes. So you need to find a blank space, and you need to write the definition of a scale factor is when we write the scale without units, which means that we must make units the same. And as what a scale factor does is it tells us how many times bigger or smaller our actual object is than our model. And so we can write that down. It tells us how many times bigger or smaller the actual object is. Because we don't always know that from the scale. We know that it's bigger or smaller, but we don't know how many times. So let's look at our scale from the skateboard ramp. So we knew that it was 1 inch equals 6 feet. But that doesn't mean that the skateboard ramp is just 6 times bigger, because I got to get these units to be the same. So I'm going to keep it in inches, and I'm going to say, okay, so 6 feet is the same as 72 inches. And so my scale factor is how I would write it. Usually you write it with the like a ratio with the colons, and when we would say it's 1 to 72. And that tells us that the skateboard ramp is actually 72 times bigger than our blueprint that we drew. All right, let's do one more. Let's take the last one that we just did. It said that on the scale, it said 1/4 inch equaled 3 feet. And so if I'm going to make these, if I'm going to try to find the scale factor for it, then is what I want to do is I want to first make them the same unit. So I want to say 1/4 inch, and so 3 feet is 36 inches. But there's another problem with this scale factor. I can't keep it at 1/4 inch, and so I need to multiply them both by 4 so that I have 1 inch equals, and 36 times 4 is 144 inches. So my scale factor is 1 to 144. It tells me that her painting on the mural that she's going to do is 144 times bigger than her blueprint.